Welcome back. In the previous lecture, we created a batch processing solution. Let me show it to you. So here is the solution. That's what we developed in the previous lecture. It was a word count problem, but it is a typical data engineering process, right? We are doing a typical thing which we do in most of the data engineering projects. We are ingesting data from the landing zone and doing the processing and finally saving the results into a final target table. That's what we do in a typical project. Our customers wanted to run this entire pipeline every 15 minutes. That looks an achievable goal, right? But let's think about it. Let's think if our customer reduced the frequency to 30 seconds. Now, they want us to run this entire pipeline and finish everything in 30 seconds. Can we do it? Can this same solution sustain this requirement? Think about it. We have one big problem here. What is that? Let me talk about it. So we have a full load process. This entire solution performs a full load process. What does it mean? Simple. We are reading data from the landing zone and then we are processing it. In the first iteration, landing zone may have 1 or 2 files ingested. We will read 1 or 2 files and process it. In the second iteration, we may have 1 or 2 more files. So the second iteration will process all the new files plus the previous files, right? In the 10th iteration, we may have 10, 15 or 20 files ingested. And the 10th iteration will process all the files that are present in this landing zone. So what we are doing here, we are loading the full data set from the landing zone, processing the full data set, and finally overwriting the result into the target table. So everything from top to bottom, from beginning to end, is a full load process. With the time, your data volume keep on increasing, and then achieving 30 seconds or even 15 minutes may be impossible. Over a period of time, your job will start taking more and more and more time, and you won't be able to finish it in 15 minutes. Forget about the 30 seconds requirement. So we have a back pressure problem here, right? We have a back pressure problem because we are doing a full load, full process and complete override. How do we solve this? If we want to really solve it, the one and the only approach is to implement a incremental data processing. So what we want to do, first iteration, whatever files are there in the landing zone, take those files and process it and write the result here. In the second iteration, whatever new files have arrived, take only those files and do the processing only for those new data set and update the result into the final target table instead of overwriting the final target table. That's the incremental approach, right? We want to do that. But how do we do that? It's not easy thing to implement that kind of solution. And that's where Spark structured streaming comes into play. Spark structured streaming makes all these things super simple. So let me implement Spark structured streaming for the same solution, translate our batch processing solution into a streaming solution, and then we will talk about it, what we are doing here. So let's start. So here is my batch word count application. You are already familiar with this code, right? What I want to do, I want to transform this code into a streaming word count. But I'm not going to change the same code. Let's keep it as it is. I'll copy it and then paste it into a new cell. Change the class name. And we will change this class to make it a streaming word count class, right? So let's start making some changes. Let me make some code changes here and then I will explain what did I change and what does it mean, right? So first thing is to change the Spark read into Spark.read stream. We don't want to read batch data. We want to read streaming data. And that's why we are changing it to Spark read stream. That's the first change. Then we come down. This is the place where we are writing the result to the table. So I want to change this to write stream. So instead of writing batch data, we want to write streaming data. And that's the second change. At very high level, these are the two most critical changes. Instead of reading batch data, we want to use spark.readStream. Instead of writing batch data, we want to use dataframe.writeStream. These two changes are the most critical changes. Other than that is some logistics. So let me add something here. That's all. So I'm adding one extra option to tell checkpoint location. And that's a kind of mandatory requirement for a streaming application. A streaming application cannot exist without a checkpoint location because a streaming application implements incremental data processing. And for doing incremental data processing, Spark Streaming gives us a pre-implemented solution of checkpointing. Checkpointing is the location where Spark Stream will store information about what is processed in this iteration. And in the next iteration, what are the new files that we want to process? All that information is maintained in the checkpoint location. Spark Structure Streaming does that automatically. All we have to do is to tell the checkpoint location, where do we want to create Spark a checkpoint for us. So that's what I'm doing here. We are almost done converting our batch application into a streaming application. Few small changes are there. The API is little different. So I have mode here and I have save as table here. These two names are changed in the Spark Streaming API. So instead of mode overwrite, we have output mode complete. Meaning is same. Mode overwrite means overwrite the result table every time. Output mode complete means give the entire output every time. Kind of overwrite the result every time. And finally, save as table changes to table. Both are same. Save as table is going to save your result as a table, and table is going to save your result as a table or send your output to a table. Names are different, but meaning is same. That's all, nothing else. But there is a small change here. The dataframe.write does not return anything, but dataframe.writeStream returns a streaming query. So we want to return that streaming query from this method. That's all. So what we want to do, writeStream returns a streaming query, and we want to return that back from this overwrite word count method. That's all, we are done. Few changes we may have to make in the final word count application. Let me make those changes. So instead of executing word count, let me change the print method. Starting word count stream. That looks nice, right? So we get the raw DF, then we create the quality data frame, and finally we calculate the result and then use the overwrite word count method to write the result. Here is the overwrite word count method, but this method returns the streaming query. So let me hold this streaming query here in a variable. That's all. I have the streaming query now, but last line is to write the result. After that, we are done. But for some logistic reasons, I want to return the streaming query from here. So let me return the streaming query. And that's all. That is all we need to change in a batch processing word count to convert it to a stream processing word count. But let's try to understand what I did. Data processing is a three-step process, right? The first step is to read the data, then process it. Process means implement your business logic, do all the transformation, whatever you want to do. And then final step is to write the result in some table or in some sink so that your consumers or your customers can get the results, read the results from there. That's what we do. Now, think about batch processing and stream processing, how they are different. Batch processing will also read data, process it, and write. Stream processing will also read data, process it, and write. The difference in batch and stream is going to be only in how do you read and how do you write. The middle part, the processing part, remains as it is without any change. And that's the magic of uniform API or unified API of Apache Spark. Spark gives you unified API for batch and stream. And what does it mean? All the processing part, at least all the processing part remains as it is without any change. So if you learn batch processing, you already learned stream processing. The only difference is in how do you read the stream, how do you write the stream. How do you read a batch of data and how do you write a batch of data, you already learned. But in the stream processing, what we need to learn is how do we read the stream and how do we write the stream, because changes are only at those two places. And that's what I have done in this code. Let's quickly review what I have done. So here is my streaming word count code. The first change I did was change the read API to read stream API, because we don't want to read a batch of data. We want to read a stream of data. And for that, we have a different API called read stream. And the read stream will read the data as a stream. It won't read it as a batch. It will read it as a stream. And the result will be a streaming data frame. That is all. So the first difference is in how do we read. Instead of reading as a batch, we read it as a stream. The second difference is in how do we write. And that's what I did here in the overwrite word count method. So instead of writing a batch data frame, what we are doing? Write a stream. Since we are reading a stream, we are processing. So result will be a stream. So that's why we need to write the stream. And that's the difference. Rest all is just logistics. So since we are writing a stream and a stream needs a checkpoint location, we cannot write a stream without a checkpoint location. So I'm telling what is my checkpoint location, where to create a checkpoint. And then there are little differences in the names of the API or methods. So instead of mode, we are saying output mode. Instead of save as table, what I'm saying is to table. That's all. The data frame.write doesn't return anything, but data frame.write stream returns a handle to a streaming query which runs in the background. I'll explain that in a later video, but we want to return that streaming query handle from this method. That is also logistics. And finally, in the main method or our word count method, we are not changing anything here. Everything remains as it is. Only thing is I take the streaming query and return that streaming query from the word count method. Why? You will learn that in a minute when we start doing testing. And that is all. My batch word count application is now transformed into a streaming word count application. What is next? How do we test it? How do we write test case for a streaming job? That's the next step, and we will start doing that now. So let me go to my workspace and open word count test suite. We have already created batch word count test suite. So I'll copy the same and then we will modify it to make it a stream word count test suite. So change the name. So what will change? What is going to change from batch test suite to streaming test suite? Almost nothing. Almost nothing will change. The cleaning process remains the same. Data ingestion process remains the same. Assertion also remains the same. The only difference is in how we run the test, right? So the first change is instead of instantiating batch word count, we will instantiate our streaming word count. Let me open it once and so we can see it. So this is batch word count, this is streaming word count. So this is the class that we want to instantiate now, right? Because we want to test the streaming word count. So I instantiated the streaming word count. Then what we are doing in the first iteration, We are ingesting first iteration of data. We are ingesting some data and then we are calling word count, batch word count. Then we are ingesting second set of data and again calling the batch word count. And then ingesting third set of data and again calling the batch word count. So batch is designed in a way that for every iteration you have to execute the batch process. But streaming process, you start it once and it will keep on running, right? So what we need to do, we need to move it from here and keep it here. Start it only once, right? That's all. Starting the process again and again is not required because it is streaming. Once started, stream process keeps on running. So we start the word count stream process. Initially, there won't be any data in the landing zone. So it will go look for data, no data is there. So it will keep on waiting for data to arrive. We ingest the first set of data here and immediately the word count, streaming word count will pick up that data and start processing. Then again wait for the next set of data. As soon as we ingest the second set of data, streaming word count will pick up it and start processing. So execution is automatic. We start it once and the stream process keeps on listening it forever until we stop it. So what is next? What I want to do after ingesting data, I don't want to immediately go and assert the result from the target directory. What I want to do, once data is ingested, wait for 30 seconds and give 30 seconds, at least 30 seconds for my streaming word count to pick up the data, process it and produce the result in the target table. So we want to sleep for 30 seconds after every ingestion and then we do the assertion. So let me prepare for that. At the top, I'll import time package, define a variable sleep time 30 seconds. And then after ingesting data, I want to sleep for the sleep time. And before sleeping, I'm just putting a message here. So waiting for 30 seconds and then sleep for 30 seconds and then assert the result. Same thing we want to do after every iteration, right? That's all. I'm done. But one more last thing. I started my streaming job here, streaming word count process here. It will keep on running. It will keep on listening the landing zone for new data arrival. As soon as new data arrives, it will start the processing and we can assert the result. Then it will again keep on waiting for the next set of data. We ingest the second set of data, sleep for 30 seconds and then assert the result. Similarly, we ingest the third set of data, sleep for 30 seconds and then assert the result. At the end, what I want to do, I want to stop my streaming query, which I started in the beginning, right? So when I executed word count, it started the streaming query. Let me quickly show you the word count method in the streaming class. So streaming word count returns me a streaming query handle. And that's why we keep on returning this streaming query handle from a couple of places. So what I want to do here is when I start my streaming query, take the handle back and keep it there. And at the end, when I'm done with my testing, I can stop my streaming query. That's all. I'm done. So we are done defining our test suite. What is next? We want to run it, right? So let's create one cell and write code to execute it. Streaming word count test suite equal to stream test suite, instantiate the test suite, and then streaming word count. That's all. We are done. Do you want to run the streaming test suite now? Let's do it. So I already have it a cluster attached. In the beginning, we are doing batch word count test also. So let me comment that so it doesn't run. I don't want to run it and keep on waiting. And once this is commented, let's run all. Failed. Let me run it again. Okay, so my streaming word count is running. Starting cleanup is done. Starting word count is stream. So word count is stream is started. Now we are testing first iteration of the batch. Ingestion is done and I'm waiting for 30 seconds so that the first batch of data is processed. We want to give 30 seconds for our application to pick up the data, do the processing and produce the results. First iteration passed. Now the second iteration. Second one is also passed. We are running the third iteration. Great. So everything passed. So we finished creating our first stream processing application. It was a word count, simple thing, but it gives us a lot for learning or starting to learn stream processing. So we stop here and start analyzing what we did, how Spark streaming works from the next lecture. See you again. Keep learning and keep growing.